So good morning, everyone, and welcome to today's webinar. My name is Sophia, responsible for curating learning events for you at Spectrum. So we are located at Duo Tower in Bugis, Singapore. Spectrum promotes a learning-focused culture, offers a place for you to work at our premium shared workspaces and carry out your meetings and events all at one place. And also we provide connections to expand businesses. So today's webinar, learning webinar is on electric vehicles in Singapore. Are we ready for the change? So before we start, let me ask you audience through a poll. I have a poll question here. So, all right, are we indeed ready for the change? What is your take? Everyone, please put in your answers. Let's give a few more seconds here. Okay, brilliant. So majority says, Dr. Anshuman, we are indeed ready for the change. Okay, I'll be happy to, let's do another poll. I want to know how many of you own or use an electric car. Okay, no surprise there probably. Majority says no, not yet. Okay, great. So interesting results we got there, Dr. Anshuman. Let me introduce you to today's esteemed speaker. He is Dr. Anshuman Tripathi, Program Director, Future Mobility Systems and Power Grids at Energy Research Institute at NTU. He joined NTU in 2012 and heads the Autonomous Vehicles, Electromobility and Energy Grid 2.0 areas of RD&D. His team of close to 30 engineers and research scientists support the government initiative to enable clean and autonomous transport solutions. I will let Dr. Anshuman share more with you on his personal and professional journey. So audience, please take this opportunity to ask as many questions as you can through the platform here. So without further ado, Dr. Anshuman, over to you, please. Thank you.
Thank you, Sophia. And I also thank Spectrum to have chosen me for this discussion on electric vehicles in Singapore. And the question that we are asking today is, are we ready for the change? So my background has been a mix of industry and academics. So I worked with industries like General Electric and Vestas for quite a number of years before joining Energy Research Institute in 2012. And together with a lot of support from different government agencies and NTU, we have grown this group, which is now called Future Mobility Systems. And we are trying to contribute to our best of capability for different upcoming deployment solutions that that we can see in Singapore and abroad. So the way we look at electromobility has changed quite a bit. And before I go into describing our point of view on the readiness, I would take a pause and explain what we have done so far in the Future Mobility Solutions group. We then will discuss about the dynamics of transition, the mindset today and the mindset tomorrow, and what are the possible disruptions that will enable us towards this journey of transition from a given solution to a new solution and the solution of tomorrow as well. So my group in Energy Research Institute is active in terms of three areas. So the first area is the technology development for converting electric vehicles into autonomous vehicles. So what we do is we do not work on regulatory process of autonomous vehicles, but we design technologies, both software and hardware, to convert these vehicles into autonomous vehicles. Yeah, so that is one area that we work on. And you can also see drivetrains, meaning the powertrains that actually propel the vehicle. And these are all electric drivetrains. The second area that we contribute is electromobility, and more importantly, on the energy storage systems that goes on board electric vehicles. So we design battery packs, we design hybrid energy storage systems like a combination of supercaps and batteries, and plug them into different types and sizes of electric vehicles to test their capability and to satisfy certain constraints of mobilities. Yeah, the third area is what we call as advanced power electronics, and this goes beyond the vehicles, and it actually couples the grid to the vehicles, and vehicles are just one load for the power grids. And what we do here is we develop transformers which can be controlled, and we call them solid state transformers. We also work on next generation of chargers which are compact but at the same time power dense. So of late we have understood that okay, having the knowledge reside in institutes is not enough for the growth of the industry in Singapore. So we have also started to contribute in terms of training with the knowledge that we have gained over the years on different drivetrain platforms that I have just mentioned, and also technologies that we have developed in-house as well. So we have a modest team of around 30 people, and we have been working in three different areas. Each of these areas have highs and lows at times, but then we have maintained a group of around 30 people. We have consulting professors from NTU, and we have quite active professors as well from different departments of NTU as well. So in terms of testing capability, there are two test facilities that the group exploits. The first test facility is in Clean Tech Park. It's a smaller test facility where we test drivetrain performances in small battery packs. But then there is a bigger one in Jurong Island, which is quite high power as well, ranging starting from 100 kilowatt onwards. Yeah, so when we look around, and we have been Googling quite a bit, what is the problem of electromobility? So I have done this for the past 8 years, and I believe some of you have done this as well. What are the challenges? So the questions that that have been asked and the challenges that have been put forth are the following. You see, so is my electric vehicle good enough to perform the same way as the internal combustion engines? That is the number one question that comes in the mind of a technical person, performance. Yeah, in terms of a normal user, what would be the cost? How many choices that we have for electric vehicles, and how much do we pay for it? The cost and the choice, the two important C's that we have. And if I own an electric vehicle, how far can I go before I charge? And where do I charge? How can I charge? So these are some of the challenges and the questions that have been posed by the users, and not just by the users. And these challenges have been the challenges for different governments as well, globally. It's not just in Singapore, but these have been global questions as well. So now, what I intend to do is to take these challenges and group them into 4 pieces of puzzle, and let's try to see whether we have solutions to these puzzles. So when smartphones started 20 years back, or mobile phones started 20 years back, similar questions were asked. When you moved from record players to CDs and then to hard drives, same questions were posed, and it is not new for these questions to pop up in terms of adaptation of new technologies, especially when these technologies have to deal with society and deal with people. And the magnitudes might be different, but the challenges, the questions are still the same. Cost, choice, performance, and if you are dealing with electric appliances, electric vehicles, for example, how do I charge them? So these are the 4 pieces of the puzzles that we are going to discuss in this particular presentation, and we will try to bring subject, which is Singapore, into this discussion as well in the meantime. So when I speak with my parents, with my mother, these are the questions that she will ask. Is it too costly? I mean, number two, what are the choices? If you go for internal combustion engines, you close your eyes and you will imagine 100 vehicles, and you open your eyes, there are thousands. How far can my electric vehicle go in one charge? I charge my vehicle for 20 minutes and it dies in 10 kilometers. So is that the case? You see, and more importantly, is it possible for me to charge anywhere in the country? So the moment I dream of charging, I should be able to charge it. Is it possible? So that is the number one problem. And these are segregated, 1, 2, 3, and 4. I have put number one issue or puzzle as the charging. So let's counter them one by one, starting from number 4, which is range and performance. Things have changed from 2010 to 2020. If I ask this question in 2010, I would have to struggle for probing for answers. But if I ask this question in 2020, or if I ask this question today, and then I have many options. You see, so from Teslas to VWs to BMs, these are exotic models maybe, but then we have Nissans, we have Toyotas, we have BYDs, we have Neos, and there are a lot of high-ranged vehicles available for you. And electric vehicles conventionally are high-performance vehicles from Z. If you really believe in terms of performance, performance can be measured in terms of the speed. Attaining a certain speed, attaining certain accelerations. So this range question is slightly outdated in terms of anxiety. The range anxiety, especially in places like ours in Singapore. So coming up are by 2025 are models which provide you a range of at least 200, 300 kilometers, so which is very decent enough for a normal user to move around in Singapore, for example, or in any mega city, for instance. You see, so the questions about how far can I travel in one charge of my electric vehicle, how efficient will my vehicle would be, and how powerful the engine would be, are slightly getting outdated. It is not just a matter of time, but it is already nicely forecast, and investments have been made by big OEMs, the likes of Audis, Bentleys, BMWs, exotic OEMs, as well as utility OEMs in terms of GM and Ford. They have made a lot of investments. So, for example, if you see the green letters, these are the announcements. By 2021, 2025, there will be a lot many models to choose from, and this from a lot many OEMs. So Asian OEMs are also catching up. So Hyundai, for example, announced 44 electrified models by 2025. So models to suit any need. So if you are a niche buyer, then you can actually go for a niche model which provides you with all the luxuries and at the same time all the performance. Performance includes range as well. Toyota, for example, every model is going to be electric or has an electric option. So it is if you buy a vehicle, a Toyota today, it will have an electric option as well tomorrow. So all these investments and forecasts are already being done and already being made, for example, and then we will be soon spoiled with choices. I believe, and I have a strong belief, that we'll have more choices if you compare electric vehicles versus an ICE, because there are new and promising OEMs also coming in, like BYD. BYD doesn't have a history of producing ICE cars, but they are the ones who are competing neck and neck with the likes of Teslas in terms of being number one in terms for selling electric vehicles. So these are the compelling factors, while all the investments that are being made in terms of electric vehicles by the traditional OEMs. So otherwise I will be left behind. I am a conventional OEM who has been selling ICE cars for so long, and totally invested in it. But when I see new OEMs coming up, and competing with me in terms of a new technology, I am prompted towards developing those as well. So by 2025, there will be 300 models and around 1,000 different choices for you to consider. And this is not small. You can be spoilt for choices as well. So number two piece of choice, number one piece of range is slowly getting diminished. Now comes the more important part, and that is the cost. You see, often we compare with what exists, and the cost can calculating the cost can be very complex if we have a complex machine being compared with another such machine. You see, so if you compare an internal combustion engine car with an electric car, the complexity that is provided by such a car is much higher, as shown in this particular graph. And it's a small cartoon that tells you that, okay, in ICE, the machine itself is very complex, but it has matured over 200 years of existence. People know how to build such a car, how to innovate in such a car, though the margin of innovation is getting minimal. But then they have also grown with the idea of maintaining and servicing such cars. What is more complex among all the vehicles is hybrid electric vehicle. Hybrid has got the functions of both the ICE as well as the electric vehicles, but then it has got the problems of both as well. And I believe it is an extremely complex machine. When we open the hood of an ICE, we worry what can go wrong, and if it goes wrong, who's going to support the servicing and maintenance of it. The simplest possible drivetrain, on the other hand, is electric drivetrain. And I will come to a reason, and this is associated with a cost. So, in case of an electric vehicle, you can divide the electric vehicle construction into two parts. One of the part is the energy storage that is seen in this particular diagram, and the other part is the way you charge, the way you propel this vehicle, and the way you charge and propel this particular vehicle. So there is a mechanism that is very different from what an ICE uses to operationalize such electric vehicles. So if you see, the battery pack on one hand might be expensive, but I will come to that in a moment. But then all other parts are getting extremely cheap, and they have been cheap all the time in terms of money. It is also very simple. Instead of having 100 plus moving parts in ICE, you have very limited, very minimal moving parts in electric vehicle, and therefore service and maintenance costs are considerably low. We have the opportunity to regenerate the vehicle energy, and therefore the service and also the wear and tear in this particular vehicle is substantially lower, which indicates that I have lesser downtime in electric vehicles, and therefore it is an excellent opportunity to use these vehicles for sharing, because they are more available on roads, for you to use, and this propels the case of using electric vehicles as autonomous vehicles in future as well. So all in all, we are moving towards a paradigm which is of electric vehicles, which are easy to maintain and less costly in terms of the parts other than the batteries. Batteries itself, as you may know, the cost of these batteries per unit is 1 kilowatt hour, for instance, has substantially reduced. The shift came in 2010, and in 2022-23, we will be at par in terms of the cost of electric vehicle with regards to an equivalent powered internal combustion engine vehicle. So the time has really come, to make this change. So from a given ICE era to an era which is purely electric vehicles era. The substantial shift happened. There was a step change, almost a step change, and in 2014, when new ways of manufacturing batteries came into picture, and as you probably know, Tesla, China, and some of these countries have been really aggressive in terms of battery technologies and the ways to create new batteries. The scale effect took place in 2018, and since then it has propelled the cost further down. So all in all, I think the three pieces, it's my firm belief that the three pieces of cost, choice, and performance, which includes range, have really come together. What is left is to see how do we charge these vehicles. We still have to think about it, and this is very subjective to a place, and that is when I take a pause and change the topic a bit, because now we are getting very subjective, because the way we charge in Singapore might be very different from the way we charge in any different geography in the world. You see, so it is important that to note, these three pieces that I just described are not absolutely decoupled. There is a bit of coupling between each of them, and they are also coupled with the way you charge these vehicles, because for example, charging might have implications on the choice. Charging might have implications on the cost, and also the range and performance as well. But we are not going to couple everything in one go and discuss this. So let me take a pause and take you to a different study that we have done about assuming that in 2050 we have a fair share of electric vehicles. And we did this exercise in the past years, and we concluded that, okay, based on discussions and with different experts globally, as well as the statistical insights that we received, we segregated the penetration of electric vehicles into Singapore transportation system into three scenarios. So there can be a low scenario, and the low scenario for public buses means that 20% of all the buses will be electric by 2050. There can be a medium scenario in which 60% of buses, for example, would be electric, and there can be a high scenario in which 100% of the buses will be electric. What does it take to do that? You see, and similarly for all other fleets of vehicles, it's not just the public buses that move around. It is also the motorbikes, the taxis, the private vehicles, which comprises of minivans and cars, etc. The freight vehicles and private buses also. So all in all, it is important to note that this is again an exercise that was done purely by the group, and we laid down different scenarios, and what does it take to charge these vehicles in each of these scenarios, for example. So we also went down and started calculating, and this is more like a small tool that we developed, and there can be more accurate tools that you can develop, but then we have matured on these tools. Just for the sake of an argument, I am presenting the very basic tool that we initially developed to come up with an assessment of number of charging stations in Singapore, and what technologies these charging stations use for a given fleet of vehicles. One fleet of vehicle, essentially going back, is public buses could be one fleet, motorcycles could be another fleet, and so on and so forth. So it is not very difficult, especially in Singapore perspective, to count the number of buses. It's a readily available data that is published in Singapore statistics. There's a website on it if you come across. So we can always calculate the annual energy demand per fleet in units of energy, which is kilowatt hour. We can also choose based on certain assumptions. We can always choose the charging technology. By charging technology, I mean, are you charging AC or are you charging DC? When you charge AC, there can be a maximum of and so kilowatt. When you charge DC, you can go to 300 kilowatt as well. So these are the charging technologies that we considered. And for that particular fleet, what is the percentage of these technologies being used? So when you multiply them, you then know the total annual energy required for a given fleet for a given charging technology. When you divide them by the number of days in a year, 365, 366, you can actually get the daily energy demand. And this daily energy demand is not is not something which is rigid. It depends on the utilization factor. So unfortunately, if I'm a normal user, my car goes to the office and it stands there throughout the day, and my utilization factor during the weekdays is definitely low for my kind of person. There can be other set of people. There can be public buses which are very highly used in Singapore, for example. See, so the utilization factor also played a part in our tool, and therefore using this utilization factor, multiplying it with the daily energy capacity based on a given charging technology, it was possible for us to come up with the number of charging stations of all types with a given utilization factor of that particular fleet of vehicles. So we can calculate for every fleet. Again, the fleet comprises of a bus fleet or a car fleet, or and so on, that I showed you in this particular slide. So it is possible for me to have an assessment of the number of charging stations for a given fleet of vehicles. Now, having done this exercise, we also sat down and said that, hey, if I have to spend money on installing these chargers and all kinds of chargers, how much do I spend? So as you know, any expenditure has got a capital cost and then an operational cost. So we started calculating them as well, and it was not rocket science to come to a conclusion for a given fleet, number of charging stations per fleet. And therefore, if we multiply for all the fleets, we can actually get some wholesome number for charging infrastructure for a given fleet and for all the fleets. Then we came to this realization that these charging loads are distributed, they are not concentrated. So you don't have petrol pumps where you go and start charging your vehicles. We have an opportunity to distribute this load. When the loads are distributed, it clearly means that the flexibility is increased, which means that it is very difficult for me to imagine a petrol pump in a shopping mall. It's not possible for more than one reason, you see. But it is very easy for me to imagine that these loads can not be concentrated in small pockets like petrol pumps, but it can be distributed like normal loads in your houses, for instance. So if the charging loads are distributed, can the charging energy source be distributed as well? And in this era of renewables, this question is this assumption is not very unfair, is what we felt. So Singapore, as you know, is ramping in terms of solar energy. Solar energy is a great option to create an alternative means to power up our homes. And the advantage of solar energy is that it is distributed. And distributed solar energy. So we try to map the possibility of loading due to different kinds of penetration of different fleets of electric vehicles, and also the possibility to use the distributed solar energy to charge these electric vehicles. And it was a simple mapping. In this year, if we assume that a low penetration scenario, which means that 20% of electric buses become 20% of buses become electrical, and high penetration 100% becomes electrical by 2050. In 2021, it means that 19,000 electric vehicles and 76,000 electric vehicles in high penetration scenario. So which means that out of the total energy demand, the low penetration scenario is only 0.1 times the total terawatt hour or total energy that we will use in Singapore. You see, in 2030, we will have 0.3 and 1.4 percent, or you can say this can also be equated to percentage. Yeah, but it is just nice, you see. So the solar energy that we can produce in an yearly basis is much more than the energy required to charge all these electric vehicles in Singapore. So for example, if solar penetration, so there is a solar roadmap as well. If the solar penetration is low, then we have only 4 terawatt hour of energy coming from solar power. You see, so if solar penetration is high, then this number amounts to 6. So the same thing goes with electric vehicle. If electric vehicle penetration is low, then we have 0.3 TWH of requirement. If it is very high, then it is 1.4. Based on our high and low and medium penetration scenarios, we came to the conclusion that, okay, it is quite possible that distributed energy will be enough to power this particular distributed segment of the load. And there's hardly any issue with that. Of course, there is some work need to be done, and I'm sure the government is following on this particular aspect of powering the vehicles as well. So if you look at energy demand, the energy demand demanded by electric vehicles in Singapore will be not much, you know. So 0.6 TWH, and for minimum penetration scenario or the low penetration scenario, and for high penetration scenario, it will be not substantial. It is less than 3 as well. So if you look at the charging infrastructure cost ranges, you know, so we also calculated that if charging is a problem, there is the problem is also the cost of it, you know. So the technologies have matured, and therefore we received a wide range of these chargers and the costs associated with it. Who pays for this cost is something which we have to discuss outside of this particular matter, but then we will come to that. I will try to hint as to who is going to pay for it in one of my slides as well. So we did this calculations, and we then took a pause again and said that, hey, if charging electric vehicles, if the energy is not a problem, distributed energy is good enough, for distributed energy resource is good enough to charge the electric vehicles, then let's see how do we map it with what we want to do in Singapore. So Singapore is very specific and it is very different. And when you go and research Singapore and compare it with other countries, you find there is a strong difference in the way transport is done in Singapore. So the car ownership, for example, is just over 10%, and this is in a stark difference from what is done in countries like US or Europe. We have less than 1 million cars in vehicles in Singapore. All the vehicles combined is less than 1 million, and it's around 950 or 960,000. You see, what is startling to note is that 16% of country's total land area is taken up by transport, and this is among the largest in the world. I mean, we are not the largest, but this is one of the largest, and in that range, the average age of car is getting lower and lower. You know, 10 years back it was higher, so people try to replace their car and they get bored of the same car in 5 years time, for example. You know, so the global trend is just the opposite. You know, people try to the ownership is much higher. The proud feeling is still there, and then so this is something which is encouraging. You know, why I say that is written in these 2 points. You know, so the government's emphasis has been on public transport, and that is not unknown to all of us. You know, so public mobility solutions are sort of not quite encouraged, you know, to grow. So and that is good, because we have limited space for people to move around. We don't have a space for more vehicles on road in Singapore. And also there is a change in the mindset of people. You know, so during the age 25 years, 30 years back, or 50 years back, people used to be proud, you know, to own electric vehicle or own vehicles, and then they try to hang on to it as if, you know, it was one of the most possessed, most important possession that they had ever. But things are changing. You know, their priorities are different. Next gen citizen has very different mindset, and it is not the ownership that matters to them. It is the usership, the access to the facility is more important. So in Singapore, we made certain decisions, and I think this is the reading what we at NTU observe through to the course of our work in the past. And it is not just in Singapore, but it is a global mandate as well. So things are changing from ownership to access. I need to access the mobility and to move from one point to another point, or to move in a zone, for instance. So that is also usership. So it defines certain term which is usership. It is not grammatically correct, but then that is the sense, or that is the sentiment that people have. Ownership to usership, for instance. Driving less, and this is very specific to Singapore. Use of public or shared transport to driverless, for example. So this is something that is that we are moving towards. And then there is a case in a point, and when I say case in a point, which I mean that if all the vehicles are connected, shared, and if they are all electric, it is possible to go into the driverless zone, which in a way increases efficiency of moving people around. You see, so we used these patterns, and we try to segregate these patterns and see how successful this usership would be, and who are the first owners of this opportunity, or this sentiment moving from ownership to usership. So we can create this sentiment by having more dynamic pricing, for instance. Which, what I mean is that the pricing should be in the user's fingerprints. So everything should be accessible to the user, and it has to be direct usership. You see, so vehicle ownership for personal mobility is neither encouraged, and nor it is going to grow, because as I said, the sentiment itself has changed, the mindset itself has changed. So that's a nice green arrow that we welcome. But there are people who get this opportunity to access the cars, or access mobilities which are shared. So that is the masses, instead of moving in public transport, might actually attempt to go to access these shared mobility options, which are now available to them on fingertips. So that is something that might be of concern. So we thought, okay, let's see whether we are ready today, and what makes us ready. So who are the first grabbers, or of this kind of usership mindset? So we thought it was optimal for us to understand that, okay, these are the ones who use cabs today. So cabs or Grab, for example, or which are still driven by people. So we did a comprehensive analysis to figure out that HDBs which house one or two people, or condos which house number of people in a house, HDB with 5 houses, HDB with 4 houses, HDB with households. House inmates, for instance, 3 people living in one HDB flat. So these are the target areas, and these are the ones who use. We spend a lot of money in terms of grabbing the cabs, or moving in Grab, for example. So these are the people who will jump into this particular opportunity. And so the opportunity in which we have shared vehicles, and the opportunity in which we have shared electric vehicles, it has already started in Singapore with the small blue SG cars moving around. So another question that we tried to address was, where should we place these chargers? And we divided, we created some zones which we felt that it has got massive density of people movement, and these zones are the zones which we believe will house around 65 to 70% of chargers that will be used by all the users of shared electric mobility solutions. And of course, the positioning of these chargers is again breaking the problem down into small units of subjectivity. So whether it is a shopping mall, an HDB estate, and so on, we have done, and there is an ongoing study with regards to that as well. But then, of course, I believe there are many such studies initiated by the government also. So with that background, I will take a pause and see what we have done over the years in Singapore. So we started off small and light in 2009. And that is when the Land Transport Authority of Singapore, together with Energy Market Authority, jumped into the foray of electric vehicle adoption. And a task force was created on electric vehicles. Since then, an important milestone came when car sharing program was initiated by the Land Transport Authority and the government themselves. So the car sharing program essentially is an indication of what we have seen from the sentiment that I tried to portray in the previous slides. So Singapore Power Group also jumped into the foray with the power perspective, and that was in 2012. In 2020 and 2021, there is a real paradigm shift when our DPM and the government announced that we are now really going towards the deployment or the use of electric vehicles, 2020, 2021. And this is not unknown to the audience that these are the path breaking, so to say, years in Singapore. So that makes me believe that we are firm towards moving towards transport electrification. That is what brings me to the conclusion, and this is not really a conclusion yet. That brings me to this belief that it is possible to bring this piece together and or closer to the entire puzzle that we have of different challenges. You see, so charger location, scheduling, fast charge, and is it possible to have charging as a service also? What remains to be solved is what is written here in the bottom of this slide. How do we have connected vehicles? How do we have more intelligent charging ecosystem? And who is going to power these these vehicles all charging at the same time? We do have energy advantage. Imagine we are using internal combustion engine, and the efficiency of these vehicles at the best of their design is only 20%. And most of them are 15%, for example. On the other hand, even a simple electric vehicle designed in a lab will give you 40% of useful work. So it dramatically changes the energy landscape. So there is definitely an energy advantage in terms of moving. Imagine we will become energy light in Singapore if all the vehicles became electric. Yeah, but there are however, there are certain reasons why we still have to do slight work in terms of powering these vehicles. Energy is power multiplied by time, but power can be something which is instant, and that is what creates problem in the power grid. So there are very heavy duty vehicle requirements. I mean, there are a lot of benefits to go for fast charging, and one of the benefits being we make the vehicle cheaper, and we make the vehicle lighter, because less batteries in a vehicle makes the vehicle lighter and cheaper as well. But then we have to create an option to charge these vehicles more frequently and more fast. So fast charging means high power, and high power means we create spikes in the in the power circuit. So having said that, it also tells me that, we don't really need to refuel it in a petrol pump again. And I'm revisiting the same point again. It is possible to bring the charger into the bus stops. It is possible to bring the charger into shopping malls. It is possible to bring the charger into libraries also. There's no noise, there's no fuel, there's no emission, and therefore it is absolutely feasible to break the myth or break the concept of going into a petrol pump and filling petrol in my car or diesel in my car, for example. So refueling can happen anywhere if we are able to solve this small power point problem. So what is this problem? And this problem essentially can be identified in this particular diagram. In Singapore, for instance, we have very strong generating base. We don't have problems in terms of generation, and we do it with natural gas, and also we burn our waste and we create power as well. There is a small transmission system which is also very strong and very rigid. We don't have issues with that as well. The problem comes in distribution networks where we are using these conventional transformers to supply to different types of DC loads. And our electric vehicle charging loads are also going to be attached additionally to these transformers, So it is not just the DC charging, DC fast charging of electric vehicles, but there are more and more requirements coming from these distribution substations or distribution transformers at this particular level. So that is where the issue is. And let us see what we have done and what people have done to solve this issue. One way to solve this issue is to generate locally. We don't have to buy or transfer power right from the power plants in a conventional way to supply to these kind of loads, these kind of upcoming loads, which have got a lot of local advantages, as we have seen, like electric vehicle loads. You see, so is it possible to use the distributed generation, as I mentioned, and supply to some of these loads, including electric vehicles? Is it possible? So we did some work initiated by the National Research Foundation of Singapore, and we tried to see, is it possible to create conduits to transfer fast chargers, to transfer power required by the fast chargers, which are DC chargers, and also at the same time cater to the load which are already existing in the building. So instead of having a transformer like this, we said that we can have a transformer that is also enabling DC transfer, and DC transfer enables fast charging, DC transfer enables coupling with DC generation, which is like solar power generation. Is it possible to do that? And we have started this work contributing to the Energy Grid 2.0 initiative by the government at the same time. And what can be done using solid state transformer is we can save a lot of space. We can save tremendous amount of space having done so. So this is a next generation of technology, and it is being practiced at a small scale in NTU, and which is now going to go into a bigger scheme of things. What is the other technology that people have worked, and in NTU we have worked as well? Instead of vehicles going to the chargers going to the vehicles. This is possible. This can be a good transition phase while we bring the infrastructure to these new locales. So this is small charging station moving around, charging vehicles in an SDB estate, for example. So we also came up with the concept of having energy plazas. So vehicles of different sizes and capacities can be charged in these dedicated energy plazas, for example. So the other point on connectivity that I made, can all these vehicles be connected? Because we have 5G knocking our door, and it's already there in Singapore in pockets, and we are experimenting with it. 5G can enable constant monitoring and connectivity of every single car with the chargers available around the country. You see, so opportunity to charge can always be known to the user. It is also possible to help the OEM to improve on this facility of using electric vehicles, for instance. And beyond that, we also feel that it is possible to easily bring up the capability to service and maintain such electric vehicles of any kind. You see, so as I mentioned in my earlier slide, that we are working towards supporting the government in this initiative as well. With all these things in place, I have a belief that we are slowly getting aligned in terms of solving this puzzle of challenges, and it is possible for us to now pinpoint on the issues, and it is possible for us to create options and innovations at a local level to solve these questions. So the question again is, I have removed the question mark in this. We are saying that, are we ready for the change? I agree with the poll that you did earlier. And I have to add one word, that we are slowly getting ready for the change. And this is my last slide. And I'm thankful to Spectrum and thankful to all of you to have given me this chance to discuss this. What I would like to say before I go, that Singapore should become a lighthouse in this case, to tell the world that, okay, this is how you should do electric vehicles. And we know how to solve the challenges in a small geography that we have. And I think I am optimistic, but that is what it appears to be from the from the slides that I have just presented to you. Thank you very much. I appreciate it.
Thank you, Dr. Anshuman. So, Dr. Anshuman, we have a few questions here. So,
Sure.
Mel, thank you for your question. Will there be a recording? Yes, we will send the recording to those who register. Dr. Majumdar, thank you for your question. So his question to you, Dr. Anshuman, statistics on slides 8 to 11 shown are for the world, isn't it?
Slide, yeah, it is global statistics. So if you see, all these statistics are essentially global until I have gone subjective to Singapore. So this is something which any country will get an opportunity to put their hands on. So they are indeed global. So they are globally available, and there's no reason why they can't be available in Singapore as well. Yeah.
Thank you. All right. Thank you, Dr. Majumdar, for your question. All right. So will there be slides shared? Yes, we will share the slides. Thank you, email. Thank you for that. Clarence asks, okay, this is an interesting question. The trial on 2 EV waste collection trucks have been a failure, with frequent occurrence of the trucks running dry on battery due to the extensive stop-start usage in the city. How can this be addressed? How about construction vehicles? How sustainable to go EV for such heavy vehicles?
Yeah, so thank you. I think this is, as I said, I showed in one of my slides that heavy duty applications are something to really worry about. And it is not a problem that cannot be addressed. And as I speak, it has been addressed technically as well. So if you see, just to give you an example, in Singapore, we have one of the important business streams as ports. The Port Authority of Singapore has rapidly electrifying its fleets that run within the ports. And now, as from what I know, we have close to around 300 electric vehicles, and these are heavy duty electric vehicles also. So these vehicles are 95-ton vehicles. A normal bus is 18 tons. A 12-ton bus, a 12-meter bus is 18 tons, while these vehicles with 2 big containers on board are close to around 100 tons. So these vehicles are purely electric vehicles run by different types of lithium-ion batteries, and they are charged at a very fast rate as well. So why I give you this example is because they run in the same environment, their loads are very high, and we have collected when I say we, Singapore has got enough data to see what is that it takes, to sustain this kind of mechanism in such heavy duty applications for long. You see, so the main failures that happen are because of slightly undervalued design of vehicles. And when you get more data, it becomes more and more clearer that, okay, given the heavy duty application in mind, and also the environmental condition in which these vehicles are being operated, we have to change the designs a bit here and a bit there, and therefore this problem can easily be solved. So I don't think it's a long-term problem. It's a problem which is again subjective to tropical conditions, but this is something that can be easily solved.
Great, thank you. So let's talk about battery swap now. We've got 2 questions on those. Hong, thank you for your question. What are your views on battery swap?
Battery swap is a great technology. I mean, it can work very well for standard applications. So it can work very well for small bikes, for example, where the user has got the freedom to do so. Which means that if I am a user of a bike, I have a battery pack that I use in my bike, another battery pack that I store in my office or in my house, and it is possible for me to manage this on my own. So it's very easy for me to do that. But when you imagine battery swapping stations, you have for larger vehicles and different makes and types of vehicles, it is a logistics problem to house different configurations on a swapping platform, and also to house a huge battery bank. Charging these battery banks to be ready for the next swaps will be an issue that has to be addressed. It is possible, but then it is, to me, it's going to be a theory that for very heavy duty applications or even for cars.
Great, thank you. That also addressed the question by Shisha. He was asking about the stations which you have already addressed. Thank you. So next question from Cindy. Cindy says, what is the transmission loss for V2V?
What is the transmission loss for?
V2V.
So vehicle to vehicle.
Yes.
Yep. So if I have assumed that we go 4G and 5G, and we did a fleet regulation exercise in NTU. We did a small fleet regulation exercise, which means that if I have connected vehicles and, for example, 2 public transport units or 2 electric vehicles, for example, we had the good fortunes of working with different OEMs, and one of the projects that we did was to connect vehicles. So if you hit 5G, then there is hardly any loss. But then if you have protocols which are less than that, then there are occasions when we felt that it should have been better. But I think this is a problem that can be addressed as well. I can't quantify the losses because I don't know what technology you are attempting to use. But indeed, this is something that that can also be solved with the advent of 5G in Singapore.
Great. Thank you for keeping the questions coming through. We'll try to address them within the time. So next question, Dr. Anshuman YS asks, with the increase in EV demand, there seems to be shortage of chips and lithium for batteries. Do you think this may actually drive up cost?
So far, we have not seen. It's an interesting question, and I think when you look at the fuel of electric vehicle, it's lithium based. So lithium is found in abundance in the world. So I don't think that should be a problem. But having said that, there are studies which suggest that in 50 years time or times to come, there could be a crunch. But there are 2 ways to address this question. So there are new technologies of batteries, like one of them is solid state batteries, done by Toyota and researched by Toyota, and you will see them soon in the market. Not in the next 5 years though. Yeah. So what is important to note is until the next gen technologies become commercially viable, we have enough resources for us to sustain the growth of electric vehicles. So I will be very cautious in answering this question, because we have also done research on what is the sustainability mechanism for electric vehicles adoption. So this question always pops up, and the best way to answer this is there is abundance of material to make batteries until new next generation of technologies take over, and it's always holding hands and passing the batons.
Thank you, Dr. Anshuman. Dr. Anshuman, would you like to stop share your slide, please?
Yeah,
because
okay. Sorry about it.
You want to see our faces.
Yeah.
Okay, thank you. Hope that answer your question, YS. So next, Paul asks, what do you feel is our level of progress and readiness against that of other countries across Asia?
it's an interesting problem. We have been cautious, as I showed you in one of my slides, that we started working in Singapore. The Land Transport Authority and Energy Market, all the leading agencies started thinking about this from 2009 onwards. So my personal take on this is that our problem is our problem, and we should not compare solving or comparing this with our neighbors, for example. I think the only way we can be a lighthouse is the way we devise solutions to the problem, which is very subjective to Singapore. And we have issues of density of people, but that is in certain pockets and in most of the pockets, for example. And we have issues of also of resources with regards to energy and infrastructure. By infrastructure, I mean we have a given percentage of land available for experimenting and trying out things. So this is a very unique set of problems, and I have tried to articulate that in my presentation. So I believe the comparison, while it sounds great that a given country has got more electric vehicles in terms of number, and they have been more aggressive, they might have started earlier, they might have learned their lessons earlier, but they have done that for their geography and their conditions. We are doing it for Singapore, and I think with regards to the progress, I believe that we are making decent progress, if not great or brilliant. Yeah.
Great. Okay, I think we have a couple of questions here which we will take offline, but probably Dr. Anshuman, if you are comfortable, let's address one or two more questions. Are you okay with that? All right.
Yes, yes.
So Dr. Manjunder asks, how do EVs compare with hydrogen fuel powered vehicles since they emit only water?
So again, my personal take on this, you see, so I feel hydrogen is a great option. So while battery-based electric vehicles or BEVs are evolutionary, they are evolving technologies, and they are evolving for the betterment, as I showed you in the slides. So while battery-based vehicles are evolutionary, hydrogen-based vehicles are revolutionary. Now, why I say this is because, as you pointed out, sir, that there are advantages of going towards hydrogen, but hydrogen itself should not just be seen as the means to power one sector of load, which is electric vehicles. Hydrogen economy has to develop, and how do we generate hydrogen, for instance? How do we use hydrogen for other purposes? And that is when it becomes more commercially viable to use hydrogen for electric vehicles also, especially in Singapore. So I think you are right. Hydrogen is something that we should always work towards, because as I said, and I repeat, hydrogen is something which is revolutionary. The only thing is it has to create more use cases for it to be commercially viable in the next 2 to 5 years.
Great, thank you. So we'll take one final question from Cervantes Lee. How is Singapore government role to continue encouraging giant private company like Grab or other smaller companies to continue innovating?
I think it all, so on one side there is user, and on the other side there are policies which are done by the government. So the government has got a vision which is beyond users, and which is beyond a given sector, which is transport. So if you look at 20 years back, and if you see now, there has been a dramatic change in how people have approached mobility. And Grab is one radical step also in Singapore. It started with Uber to begin with, and then it moved to Grab, of sharing the resources. So that prompted people to change the mindset. And I think it's a nice, there will be always a nice point when people believe that, okay, for the concept of grabbing vehicles, how do we go to the next gen in which I as a user will have a choice, which is beyond Grab. You see, so that is something that we have to look at rather than Grab is a solution. Grab is a stage in a point, I believe. But then a better solution will be something which is beyond what we see today, and including shared and driven vehicles. Yeah.
Thank you. With that, I'd like to thank Dr. Anshuman and Energy Research Institute and NTU for your sharing. I hope that you, like me, have gained valuable knowledge from today's webinar and how we can contribute to a greener and sustainable future as well. So I'd like to thank you, audience, for your questions as well. So if you want to reach out to Dr. Anshuman, you can, reach out to me. I'll be happy to bridge that connection. Do complete the quick feedback form after you exit from this webinar. So I echo Dr. Anshuman's views to say that electric vehicles in Singapore, yes, we are getting ready for the change. So with that, I'd like to see you at our next webinar. So look out for email or follow us on LinkedIn or Facebook. So thank you, everyone. Stay safe and keep well. Thank you. Bye-bye.
Thank you, Sophia. Bye.